Welcome back and welcome to the start of a new unit. In our last unit, we talked a lot about different kinds of functions, telling stories with functions, function notations, and in this unit, we're going to focus in on linear functions, which are functions of lines. So after today's lesson, you should be able to determine what a linear function is from either an equation, graph, or table, and you should be able to determine slope of a linear equation from a graph or 2 points. So let's start off with what the difference is between linear and nonlinear functions. So let's define a linear function. A linear function is a function that has a constant rate of change. Keyword here is constant, meaning constant means the same. So it changes at the same rate. And it forms a line when graphed. You've been working with lines for a long time in middle school, and none of this should be new. It should all be a review, but I'm going to take it slow because I know that it can be really difficult to remember all of the things in math that we've learned in middle school. So let's take a look at the differences between a graph, a table, and an equation when it comes to a constant rate of change in a linear function. So I've given some examples of graphs, tables, and equations here. So this first graph right here, okay, that graph is a line, so we can call that linear. It forms a line, and more specifically, it forms a straight line. So this is, yes, it's linear. That is a line, it forms a straight line. We can call that a linear function. Okay, versus the graph below it. The graph below it forms a curve. You can see here that it curves down and then back up. That is not a straight line. Okay, so that is not a straight line. If I can spell straight correctly. So this is not a linear function. So that's the difference in a graph between a linear function and a nonlinear function. There are lots of examples of nonlinear functions, plenty as you start to get further along in math, but this is a basic example here. How about in a table? In a table, we're going to talk about that idea of a constant rate of change. So rate of change is describing how something is changing over time. So if I'm looking at a table, I've got X values and Y values. I'm going to look at how much each one is changing when it bumps from the next one to the next. So X is going from 1 to 2. That's a difference of 1. When it goes from 2 to 3, that's also a difference of 1. And when it goes from 3 to 4, also a difference of 1. So that rate of change is the same. It's going up by 1 every single time. For something to be a line, or to be linear, the Y values also have to be going up by a constant rate of change. So from 10 to 15, that's a change of 5. 15 to 20 is a change of 5. And 20 to 25 is a change of 5. So yes, it also has a constant rate of change. Even though the 5 and the 1 are different values, they're still going up by a constant rate. So this is a yes. It's a linear function. Okay, the rate is constant. On both sides. Okay. The second table, if we take a look, I'm going to have on my X values, I'm going to see that from -1 to 0, that's a change of 1. From 0 to 2, now I have a change of 2, which is kind of a red flag. From 2 to 3 is 1, and from 3 to 4 is 1. Is that constant? Is that the same value every time we're going over when we're increasing? No, it goes from 1 to 2. It has a change of 1, and then it has a change of 2. So already I can see that right there, that 2, is going to make this not linear. Even though on the bottom, if we take a look at the bottom, this is going up by 5 every time. It has to have the constant rate of change on both sides. So this is not linear. That 2 is really messing up that table to be linear. That is going to be a different type of graph. Okay. So what does it look like then in an equation? In an equation, and we've looked at several equations so far in this semester. In these particular equations for a linear function, we have to have a few things be true. We can have no exponents, no variables in a denominator, let me put that down here, in denominator, and no absolute value. Okay, so if we keep these 3 things in mind, that'll help us really decide. So if I look here at y equals 2x plus 1, I have just one y, just one x, no exponents. So that's a yes, that is a linear function. The next one, 2x plus 3y equals 6, I have just an x, just a y. So that's also a yes, that's a linear function. You may have heard y equals mx plus b. That's sort of what the equation at the top is. It's in y equals mx plus b. We're going to talk about that in another lesson. But these are both linear functions. They have an x and a y, and they form a line. In the last 2 examples here, I've got this y equals 2x squared. Red flag is that 2 as an exponent. That means that this is not going to be a line. In fact, this graph sort of makes a curve like this. If you were to graph that in our calculator, it would look like this, or graph it by hand. The second example has these absolute value bars here and here. Okay, this example I picked because this graph forms this kind of graph, this V, and while it has straight lines, it's not considered a linear function because it goes the rate goes down and then it goes back up again. Okay, so these examples up top are yeses, and the examples down below are going to be no's. So that's the difference between lines and graphs, lines and tables, and lines and equations. So let's move on to talking about something really important in a linear function, and that's this concept of slope, which I'm sure you have heard of before. So slope is the rate of change of a line. It's the value of the rate of change of a line. We can also call this the steepness of a line. So if I were to read this statement out, say we only know if a function is linear if it has a constant rate of change. And constant means the same. It has the constant rate of change, the same rate of change. It always stays the same value. We call this special rate of change the slope. Okay? We can say this is one value as well. Okay, so there's several different ways to think about slope. We have 4 different types of slope. A line can either be one of 4 things. And I've put these penguins on. I've given you this image of penguins skiing because I think that when we're looking at the different types of slope, it's really helpful to put a real life example to it so we can remember whether we're increasing or decreasing. So if I'm looking at this first penguin here, this one right here, that guy, that is a penguin and he is going up that line. So he is going up. So when we think of up, we think getting bigger. So this is increasing slope. He's going up the hill. Okay, another way you can think about this that might help, and this helps a lot of students, is if you draw your name from left to right along the bottom of the line or the top of the line, is your name going up or down? In this case, my name is going up, and when I think up, I think increasing. Okay. For the second line, that penguin is going now down the slope, right? If that's a ski slope, he's going down, so this is decreasing. And if I write my name here again, along the bottom of the line, notice that my name reads downwards. Okay, my name is going down from left to right, like reading a book, so that's decreasing slope. On the third one, he's not going anywhere. He's just standing on the land. He isn't going up. He's not going down. So that has a slope of 0. Not going up, not going down. There is no value there. It is 0. And then the last one, the last type of slope we have is this penguin going straight up and down vertical. Now, that would be very scary. We call that undefined. There is no value that is happening there that we can call a vertical line. So we call that slope undefined. It has undefined slope. We can't assign it a value. So these are the four different types of slope we're going to be looking at. So if I were to ask you the question, is this slope positive, negative, 0, undefined, you should be able to look at the slope and tell me that. Okay, so we're going to take a look at some graphs. And we're going to be able to find slope from a graph. The value of the slope, so finding the slope's value from the graph and determining whether it's that positive, negative, 0, or undefined. So we have this idea of slope, and that's that slope equals rise over run. So m is just another word, another way we represent the word slope. We call it m. We don't use that variable really anywhere else except here. We won't pick m as a random variable because m really means slope. M, we also can say, is how much a line is rising over how much the line is running. And what this means is that we're looking at the rise being that vertical change. And we can say that is how much up or down. That's why it's called rise, but we can also call that down as well. And then over the horizontal change. And that's how much left or right. So it's always the up or down first over the left or right second. And that's going to create a fraction that we will have to simplify to get a single value called slope. So let's take a look at some examples of this. So example 1 just says determine the slope of the line. Okay, I'd also like you to here, we're going to state whether it's positive, negative, 0, or undefined as well. So for letter A, the first thing you've got to look for are 2 points that cross the grid exactly. So I look here and I can see that this dot touches it exactly. I'm going to make it a little darker for you. It touches here at this dot. So those are the 2 dots that we have to work with. Now, sometimes you may not be given 2 points. You will have to find those 2 points on the grid, and we're looking for those points that cross the grid at an intersection point, right? So like this guy right here that I'm circling would not work because it's not on the grid. And I'll show you some examples of that in a bit. But let's first look at these 2 points on example A. So if I want to do my vertical change on how I get from point A to point B, I'm going to count up. 1, 2, 3, 4, 5, 6, 7. It takes 7 values to get to the top of the next point. So I'm going to say m equals, my vertical change is 7, my rise is 7, and then my run is 1, 2, 3, 4. So 7 over 4. So that means m equals 7 over 4. My slope is 7/4. And this is positive because it's going up and to the right. Also remembering, if you're not sure again, whether it's positive, negative, you can't remember, write your name on it. If I write my name here, my name is reading up and to the right, it's going up, and up means positive. So that's always a way to help yourself know whether it's positive or negative. Okay. Letter B, I've got my 2 points here, point here and a point here. I'm going to do my rise over my run. So I'm going to start at this point over here, and I'm going to count up 1, 2, 3. So I'm going to go up 3, and then over to the left 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 over 9. Now, I always need to check if I can simplify slope. I don't want to just leave it as 3 over 9. Now, I know I can reduce that, But if you're not sure whether you can reduce it, you can always go to your calculator. So we're gonna go to the calculator and we're gonna do 3 divided by 9, hit enter. It gives you this decimal, but remember I've talked about using that fraction button. So math, enter, enter, and it reduces to 1/3. So we're gonna go back, and instead of saying it's 3/9, we're gonna say my slope is 1/3. Now this slope, if I put my name on it, my name is going downwards, so that means that this needs to have a negative symbol with it. In fact, I'll rewrite that here. So this was 1/3, so this should have been negative 1/3 because it's going down, okay? So we tack a negative symbol on in front of the value to make it negative, okay? And we can even write negative here. This is a negative slope. Okay. This last one's a little bit hard to see, but the line here is going straight across left to right. A little bit hard to see. But when we have a line that is horizontal and going straight left to right, that just has a slope of 0. So we can just say m equals 0 and be done. We can't find a rise over a run because we're not going up, we're not going over. It's just a flat horizontal line. That is a slope of 0. 3 more examples here. Gonna highlight my points. This is a vertical line right here in letter D. So it's kind of, again, a little bit hard to see, but this is a vertical line. And vertical lines are scary skiing. Going straight down, that is undefined slope. So this slope for letter D is undefined. It's not positive, not negative, it is undefined. It also kind of brings us back to that idea of whether something's a function or not. Remembering that vertical line test where if we drew a horizontal line through the middle, that meant it was not a function. Well, something that's not a function can't be a linear function, therefore it's undefined. So it kind of brings those two things together. Example E, I have my 2 points here. Okay, I could also make another point down here. You can kind of see that the line touches the grid exactly right there. So feel free to make those points as you see fit when you see them, because you can find slope between any points along the line and it still be the same value. So I'm gonna go ahead and do my rise. So I'm gonna go up 1, 2, 3, 4, 5. So m equals 5 over, and then my run is 1, 2, 3. And this is a positive line, so m equals 5/3. Again, it's positive because it's going up and to the right, but you can always check by writing your name on it and asking yourself, does your name go up or does your name go down? If it goes up, it's increasing and positive. If it goes down, that's decreasing and negative. Okay. The last one, we've got our 2 points. I'm going to say m equals, here are the 2 dots. For this one, I'm going to go up 2, also over 2, and what is 2 divided by 2? It is 1. And this is increasing, it is positive. We can also go ahead and add up to here. Go back up to here, please. And we're going to add increasing, and we're also going to add positive to this. And we're going to add negative. I want both of these on this definition. Is one's increasing, one's decreasing, and the increasing is positive, decreasing is negative. Especially because when you write your slope, you're going to have to put a negative sign in front of the slopes that are negative. Okay? So that's finding slope from a graph. But what if we want to find slope and you're not given a graph, you're just given a couple of coordinate pairs? Well, we have to keep in mind again that slope is your rise over your run, and your rise happens to be your difference in y values. So how is y changing? And then your run is, well, how is x changing? And we use this formula right here. These are the y's changing. So it's y2 minus y1, which is 2 of the y values subtracted from each other, over x2 minus x1, which are 2 of the x values subtracted from each other. Okay, so we can make a little note here that this is saying, well, how does y change? for the top. And on the bottom, how does x change? Okay. So let's take a look at how we're going to use this formula. Determine the slope of the line to the given point. So I know that I'm going to have to use this formula, and what will really help me out is remembering that a coordinate pair is always x comma y. That is how a coordinate pair is always written. So I can label these. I can label this as x1 and x2, and I can label this as y1 and this is y2. Okay, because I've got one y and one x, and I've got a second y and a second x, so this is how I would label it. When I go to set up my formula, I'm going to write m equals, I'm going to make a line because there's this line in the formula right there that I'm highlighting with blue. There's that line, that fraction symbol, because you're going to divide the two values. So I'm going to go ahead and make that line for myself. And I'm also going to realize that within the formula, there are two minus signs. There's a minus sign here on top, and there's a minus sign there on bottom. So when I go to make my formula, I'm going to put a minus sign on top and a minus sign on bottom before I plug anything in. I call this a skeleton. Okay, we're just putting the formula out there before we plug anything else in. And now all I need to do is take the values I've labeled and plug them in properly. So in my formula, the first value is y2. Well, y2 is 3, so I'm going to put a 3 here. My y1 value is a 1, so I'll put a 1 there. x2 happens to be 4, and x1 is 1. So now I've plugged in all of my numbers into my skeleton formula. Now I have to do the order of operations. So on the top, 3 minus 1 gives me 2, and on the bottom, 4 minus 1 gives me 3. So I have a slope of 2 over 3. Okay. I could check in my calculator if that reduces. It does not, so I'm just going to say 2/3 is my slope. That is the rate at which my line is increasing. Okay. So let's try a couple more. So for letter B, I'm going to go ahead and label -4x1 and 8x2. I'm going to label the 5y1 and the -5y2. I'm going to set up my skeleton. So m equals a fraction bar and two minus signs, and I'm going to plug my values in. So y2 is -5, and y1 is +5. On the bottom, x2 is -8. And be really careful here, x1 is -4. Notice that on the bottom I have two minus signs. I've got one here and I've got one here. That's really important because it's really easy to make a sign mistake here if you don't include both those negatives. That's why I draw the skeleton first. So -5 minus 5 gives me -10. Again, if you're not sure of the mental math here, use your calculator to help you. And on the bottom, these negatives become positive, so it's really like -8 plus 4, which gives you -4. When I reduce -10 divided by -4, I get 5 over 2. Okay, and if you'd like me to show you that on the calculator, -10 divided by -4, math, enter, enter, I get that 5 over 2. Okay. Two more examples, and these are important ones because they do something a little funky. So now I've got 5,9 and 3,9. I'm going to set it up the same way. M equals my bar, my minus signs for my skeleton, label x1 and x2, label y1 and y2, and then plug them in. So on the top, I'm going to have 9 and 9. And on the bottom, I'm going to have x2 be 3, x1 is 5. Notice that when I simplify the top, 9 minus 9 is 0, and 3 minus 5 is -2. Well, what's 0 divided by anything? 0. So the slope of this line is just 0. And that's okay. You might get 0 sometimes. Slopes of lines can be horizontal, and that will have a slope of 0. Letter D, last one. M equals, draw your bar, draw your two minus signs, label your coordinate pairs. This is x1, x2, y1, y2, and then plug them in. So I'm going to have 5 minus 8 on top, and on the bottom, -7 minus -7. Two minus signs again, so be careful. 5 minus 8 gives me -3. And these minuses become a positive, pluses. And so -7 plus 7 is 0. Now all of a sudden I have a 0 in the denominator. And that should be a big red flag. When we have a 0 in the denominator, that is undefined. We cannot divide by 0. And if you were to test this by putting it into your calculator, -3 divided by 0, the calculator should pop up with an error. This says overflow error. Your calculator might say other type of error, but it should give you an error. You can't divide by 0. That's a big clue that, hey, this is undefined slope. This line will be a vertical up and down line. Okay. So that's all I have for you in this lesson, being able to figure out whether slopes are positive, negative, 0, or undefined, finding the slope from a graph, rise over run, determining whether something's linear or nonlinear, and finding slope through 2 points. If you have any questions, please ask, and good luck on your practice.